Welcome, class, to our lesson on automatic transmission fluid, filters, and coolers. This kind of begins our section on torque converters and hydraulic systems on automatic transmissions. Our automatic transmissions work off hydraulic principles. So this is kind of the lifeblood, you might say, of an automatic transmission. Our main objectives is we're going to talk about the different types of automatic transmission fluid, specifications connected to those, what those specifications mean. We'll obviously talk about the purpose and function of automatic transmission fluid. Then we'll get into automatic transmission filters, heaters, and coolers. The main purpose or function associated with transmission fluid, there's actually a list of them. Obviously, it transfers power in torque converters. This fluid is what actually allows the torque converters to work, and you'll understand that better when we go through torque converters. Without that fluid pressure, torque converters don't operate, and we don't have any power transfer from our engine into our transmission. It provides the pressure for our clutches and bands. Again, without this fluid pressure, we have no way to apply these bands and these clutches, which hold our gears, which allow the transmission to move, or I should say rotate, which then moves the vehicle. It's a lubricant. All our bearings and bushings, gears, all that needs to be lubricated, and it's done through automatic transmission fluid. This automatic transmission fluid, when it absorbs the heat of the transmission, we run it through a cooler. That heat is then dissipated, returned back to the transmission, and then the process starts all over again. It also can be used to heat it, depending on the configuration of the cooler, depending on certain devices, which we will talk about that. It actually helps get in colder situations, get the transmission up to temperature. There's an ideal temperature that we want our transmissions to run at, and we'll talk about that a little later also. Some more purposes and functions of transmission fluid is the friction attributes of transmission fluid, and we'll talk about this. You can put the wrong transmission fluid in, and it doesn't have the correct friction, what we call modifiers, which will cause improper clutch and band engagement, cause shifting problems, and could ultimately cause transmission malfunction. And I mean, we just talked about this. It's used to apply clutches and band, and it does that by being directed and acted on by valves and solenoids if it's electronic. And we'll get into that when we go through more of the hydraulic operation of the transmission. Kind of the background of transmission fluid. Some of your early transmissions used an engine oil. They didn't have a specific transmission fluid. It's a fluid And as we'll talk about Pascal's law, it'll operate as far as a fluid goes and can be used as a hydraulic fluid, can use to operate devices. However, there's a difference between engine and transmissions. What's needed for an engine isn't necessarily what we need for a transmission. So they started designing fluid specifically geared toward automatic transmissions, and we started seeing this about in the late 40s. Our modern transmission fluid has various additives added to it, and depending on the type of fluid, the type of transmission will alter what additives are in that fluid, okay? Because depending on what additives are in there, that could alter how the transmission shifts, how it operates, and even the longevity of the transmission. Some common additives. First, we got detergents and dispersants. If you don't have a pen or paper, I would recommend taking notes as we go through this. I just can't put everything in the PowerPoint. I mean, I could, but it would take a very long time. So you could write some of this down. You could probably print the PowerPoint off if you had access to a printer, or you could just have a notebook and record notes as we go. But detergents, dispersants, we actually need to keep this transmission clean. If it didn't have that, we'd have greater risk of valve sticking, getting sludge and stuff build up on valves and other stuff. Oxidation inhibitors. This reduces oxidation and decomposition of the fluid. In other words, it helps that fluid last longer. It doesn't break down. It doesn't start building varnish or sludge up on the different metals in the transmission. And this is a big deal when we're talking about valves, because once we start getting into the valves in a transmission and the valve body, very tight clearances, very important that we keep these valves and the valve body clean, or we're not going to get proper shifting out of the transmission. We have additives in there to improve what we call viscosity index improver, similar to engine oil, to where we can change the viscosity of the fluid depending on the temperature. So in colder temperatures, we can get that fluid to be a little thinner in essence. And at warmer temperatures, we can get it a little thicker, just to help the transmission operate. A transmission operates differently at different temperatures. With thicker fluid, in colder temperatures, the transmission has a tendency to shift a little later and a little harder. It's also a little harder to get that fluid lubricating all our components. So that's what our viscosity index improver is all about. We have friction modifiers. This changes the coefficient of friction in our vehicle, in our transmission. This is important because when we get into our multi-disc clutch packs, when we start talking about our lockup torque converters, that they have friction material on them. The design of that friction material and how they apply the clutches, how they apply the bands, varies from vehicle to vehicle. We need to make sure we have the proper friction modifiers in our transmission fluid, and we'll talk about transmission fluid and its relationship to the transmissions that we're putting in. In other words, we want to make sure we're putting the right fluid in the right transmission. We have foam inhibitors in there, prevent air bubbles, the fluid foaming. You can still get fluid foaming in certain circumstances. Why we don't want it to foam is that's air bubbles. When we're talking about a hydraulic circuit, and those of you who've had brakes understand this and went through this, or anybody that's had brakes that have a mushy brake pedal, that's because you may have air in the system. Air compresses. Fluid does not like to compress, okay? So if we get air in a transmission fluid, it's going to compress, we're going to have shifting problems, or we're going to damage the transmission. We have seal swelling agents. It helps the seals swell and expand to accommodate for wear that happens in the transmissions. We'll talk about the different types of seals a little bit, but we need those seals. When we go to apply clutches, we've got to apply fluid to the back of a piston, and the seal is on that piston so fluid doesn't go by the piston and vent out, and we don't apply a clutch pack. And again, this will make more sense when we get into our internals of our transmission and start talking about clutch packs. Anti-wear agents just helps reduce friction and scoring and damage to our components, bearings, bushings, things like that. Rust inhibitors. We don't want rust in our transmissions. Some of our older valve bodies were cast iron. They might have steel valves in a cast iron body. Obviously, we don't want that rusting. If we get rust on stuff, on our metal objects, and it falls off, we can get it sucked up into the transmission and cause all sorts of problems there. Corrosion inhibitors, obviously, we don't want components, metal components, to corrode. We got what they call metal deactivators. This is also part of our oxidation inhibitors. It helps form protective film around metal objects. And then dye. That is why almost all our transmission fluid is red, because they put a dye in it to make it red. That way we can kind of differentiate transmission fluid from other fluids. Here's a picture just of transmission fluid coming out of obviously a transmission. This is a nice red transmission fluid. That's kind of what we want. When it starts getting brownish in color or black and burnt, that's when we need to see about repairs or replacement. And when we get into transmission service and diagnostics, we'll talk more in depth on how to diagnose transmission issues or a need for service by looking at the fluid of the transmission. Types of transmission fluid. There are three basic types of automatic transmission fluid: non-friction modified, friction modified, and highly friction modified. The non-friction modified are transmission fluids that didn't have any friction modifying additives put into them. To my knowledge, No current vehicle is using that type of transmission fluid. A really popular one used to be Ford Type F. This is commonly used in transmissions that use primarily bands instead of clutch packs. Some of your old hot rodders would put Type F in their racing transmissions. The idea is so the clutches engage really hard and there's no slippage. And we'll talk about this more deeply when we get into multi-disc clutch packs. We have fiber clutches in a clutch pack, and if you've ever seen them, our manual transmission clutches, they have fiber material like that, and they're stacked in a group along with alternating steel plates. Well, when you apply pressure to a piston in a clutch pack, it squeezes that clutch pack and tightens it up, and then that clutch pack's attached one way or another to a gear element of our planetary gears, and it holds that gear. What happens is for comfort, they take different steps into allowing those clutches to gradually engage with each other. When you think about a manual transmission, when you learn how to drive a manual transmission, you learn how to slowly let out on the clutch as you're putting the gas on to accelerate smoothly. If you just let the clutch out real fast, it wants to jerk or maybe even stall the vehicle. If you're accelerating real hard, you can just do what we call dumping the clutch, burn the tires off, and take off. The principle behind letting it gradually, it slips a little bit, but it makes a nice gradual engagement. If you just hit really hard, it would shift real hard, and customers would complain. In non-friction modified transmission fluid, it doesn't have any additives to help those clutches slide or slip together. When they grab, and they engage really hard. That's why hot rodders used to put in other transmissions in their racers. So the idea is if you're slipping them a little bit, you're burning them a little bit. And however, in most applications, you're not going to cause much issue with a little bit of slipping. Then you have friction modified. This is where they started putting friction modifying elements, additives in the transmission. This is probably more your 60s and 70s into your 80s transmission fluids. These are pretty common. Your Dextron, your Mercon, some of your more common transmission fluids that they use for a really long time in automatic transmissions. Then you had your highly friction modified transmissions. This is where we started getting into your newer transmissions. This is our ATF plus 4, our Dextron 6, our Mercon 5, where we're starting to get, because of the material and how we're shifting that transmission, we're really sensitive on how that friction modify additive is in there. If you use the wrong type of fluid in a transmission that calls for highly friction modified transmission fluid, you can damage the transmission. We also have synthetic automatic transmission fluid. This is essentially a man-made fluid. It is not refined from anything naturally occurring. We don't need to get real deep into the different groups of synthetic transmission fluid. They are grouped in 5 different groups, and there's different levels. Group 1 really isn't, to my knowledge, isn't being currently used in any automatic transmission fluid, where Group 3 you kind of find this in your fill for life transmissions. They come out, the manufacturer says, we filled that transmission up, you never have to service that transmission. I personally don't believe in that. If it's got a drain and a refill procedure, let's put it on a maintenance schedule. And we'll talk about that in more depth when we get into the servicing automatic transmission fluids. A Ford Escape Hybrid is kind of a pretty current, newer example of a fill for life transmission, where Group 5 is kind of your high end. Royal Purple, Red Line are examples of a high end synthetic fluid. A lot of your newer transmissions use synthetic fluid. They are more expensive, but the idea is they're supposed to last longer, and they're supposed to give you better properties when it comes to viscosity and temperature. But definitely, if your transmission calls for it, you would want to put synthetic fluid in it. And we'll talk a little bit more about what fluid we add to what transmission. Some examples of ATF, if we go through some of your more common automotive manufacturers. General Motors, we could go through each single type of fluid they ever made, but I want to start with kind of like the Dextron. Dextron 2 up through Dextron 3 was used for quite a few years in General Motors vehicles, from the 60s clear up into the mid-2000s, early 2000. Very common transmission fluid. Then they jumped to a Dextron 6, which I believe is a synthetic, in their 2005. We first seen this in their Allison 5 and 6-speed transmissions, I believe. And GM has kind of retrofitted that to all their older transmissions. So essentially they say you can flush out older transmissions when you're doing, say, a fluid flush, and put the Dextron 6 in place of where the Dextron 3 would go. But you wouldn't want to put Dextron 3 in the place of where Dextron 6 is. But if you see Dextron, that's a real common GM automatic transmission fluid. You found it in other vehicles also. A lot of different vehicles use Dextron transmission fluid. I think Eva's Opel uses a Dextron transmission fluid. Ford, remember we talked about Type F. That was used early on, but then for Ford it was Mercon. The Mercon is what they used for many, many years. And matter of fact, for a lot of times you would buy a Dextron Mercon fluid. It was kind of a universal fluid that you could put in Ford or GM vehicles. A lot of times you probably go to Walmart today and get a Dextron Mercon transmission fluid. Then Ford jumped up to a Mercon 5 that in some of their newer vehicles. That was about the step up that General Motors when General Motors put in their Dextron 6. Ford also has a Mercon LV, which means low viscosity. And I think one of their newest one is a Mercon SP. These are just kind of examples that I'm trying to put out there of the different transmission fluids. A real popular one for Toyota was the WS, World Standard. Toyota used this in a lot of different transmissions, or they would just say sometimes you just have a designated Toyota transmission fluid. Chrysler, the ATF plus 4, that's what they use in most of their vehicles. Before that, they were using ATF plus 3. A lot of times before that, you could use a Dextron Mercon in the Chrysler vehicles. But if you see an ATF 4, that is their most current transmission fluid. And a lot of times, not a lot of times, when they came out with the ATF 4, they recommended changing everything that had ATF plus 3 to ATF plus 4. So if you brought a vehicle in with ATF plus 3 and you needed to service it or do a fluid exchange, a fluid flush, you would do it with ATF plus 4. Those are just kind of some different examples. There's a lot of different transmission fluid out there. You want to make sure that you put the right fluid in with the right transmission. That kind of leads to this slide right here. There are, we'll talk about multi-vehicle transmission fluids, but the big thing is we want to make sure whatever fluid we're putting in there meets the specifications requirements that the manufacturer asked for. Again, we would not want to take Dextron 2 and put it in a vehicle that takes a Mercon LV or an ATF plus 4. We could cause shifting problems at the least. To the worst, we could damage or ruin the transmission. Okay? Make sure we're using the proper fluid when we're either filling up, servicing, flushing the vehicle. Okay, now we've talked about using the correct fluid. Now we have some options when it comes to what fluid we put in our vehicles, what fluid we put in our automatic transmissions or transaxles. You could use the exact fluid that's specified by the manufacturers. If it calls for a Dextron 6, you put in a Dextron 6. If it calls for a Toyota WS, you put in a Toyota WS. Nothing wrong with that. But that is not what we have to do. Most independent repair shops, now if you work at a dealer, you work at a Toyota dealer, you're going to be putting Toyota fluid in your transmissions. But most independent repair shops, that is not cost effective to have that many different types of fluid, because there are a lot of different types of fluid out there for each vehicle they may see. Okay? As a matter of fact, in most shops they have a chart. This vehicle should take this fluid, and then what happens is and this is where we're at now, option 2, will my multi-vehicle fluid cover this vehicle? This is what many independent repair shops do, is they use a multi-vehicle fluid. This is a synthetic fluid that is designed with the right additives to work in many different types of vehicles. There's a lot of different brands out there, and on the container itself, it usually tells you what transmission fluids and what factory transmission fluids this will work with and what ones it won't. A lot of times you can get a chart if, say, you're using a Peak multi-vehicle transmission fluid. You can usually get a chart from Peak to say what fluids will this replace and what fluids will it not replace. Because rarely will a multi-vehicle fluid cover absolutely every single transmission fluid. Usually there's some that it won't. Okay, this is the most common method that most independent shops use. This is probably the most common thing that I use even on my own personal vehicle is multi-vehicle fluid, because a lot of times not only will it cover your newer stuff, it'll cover a lot of your older transmissions also. A third option is where we take what we call a standard ATF or a baseline ATF, and we use a top-off treatment or additive to go with that. This is not used very often anymore, to my knowledge. Some shops do still do this, and maybe more than I think they do. I know in the early days of Chrysler, when they were still using hydraulically operated transmissions, when they were just switching to ATF +3 from Dextron, you could put the Dextron in, and a company called LubeGuard had an additive that you could put in with Dextron that would then meet the standards of ATF +3. Because what would happen if you used regular Dextron, the valves and the governor on these transmissions would stick. And you would do a filter change, or I used to rebuild a lot of those transmissions, well, Chrysler 3-speed transaxles, I should say. And when I started rebuilding them, we put Dextron in them, and they'd want to not upshift. I'd put the LubeGuard additive. It would help formulate it like the ATF +3, and they would shift just fine. But that would be your third option. Here's a picture. This is a Honda Genuine ATF Z1 fluid. This is a fluid that Honda actually used for a long time. This would be an example of using the exact fluid recommended by the manufacturers. Again, I have no problem if you want to do this. If this is the route you think is best, no problem with it. But I also don't have any trouble with using a multi-vehicle universal transmission fluid. Okay? Here's an example of one of those. A lot of these on the front or the back or both, they'll tell you what fluids it'll cover and what it won't. I usually stick with a more common brand. I like using Valvoline, has a pretty good universal one. Peak, I use a lot of Peak universal transmission fluid. And it'll tell you right on there what it will work with and what it won't. That'll help you decide whether you can use that or not. Because a lot of times the universal will be less expensive than a factory transmission fluid, especially when we're getting into synthetics. Here's a picture of an additive. Okay. This is an example of the additive that I was talking about earlier for Chryslers. Okay, usually they tell you what the base fluid should be. Here it tells you converts dextron 3 mercon into a more highly friction modified automatic transmission fluid. Okay, this might not work if you started, most likely wouldn't work if you started with a type F. If you tried to start with a type F, then it probably wouldn't work if you tried to get to a ATF plus 4. Okay. A lot of times your dextron 3 or mercon is your base, because that was used in most vehicles. Ford, GM, Chrysler, earlier Toyotas, all used some form of dextron earlier in their transmissions. So when we started seeing these more highly frictionized modified ATF fluids, that's when you first started seeing this additive that was put in to help with, put in with dextron 3 to help meet these specifications for these other transmission fluids. Again, with as inexpensive as and as common as these universal transmission fluids are, you don't see this done as often as it used to be. Now that we're done talking about fluid itself, we're going to talk about filters. There's not a whole lot we need to go in here. The basic purpose and function of a filter is to filter out contamination, okay? Whether it's dirt, metal or foreign particles, anything that could get into the transmission, cause valves to stick, or cause bushings or bearings to wear out or become damaged, we want to try and filter those out, okay? Transmission filters, they can come in a lot of different shapes and sizes. You just have to see what your manufacturer is calling for. Here is a pretty common example of a transmission filter where a transmission or transaxle, this is a transaxle, has a pan on the bottom of it. You can take that pan off and there will be a filter in there. Often will look very similar to this. Very, very common. In order to service these, you would unbolt that pan. If it had a drain plug on the pan, you would drain the fluid first. A lot of times it wouldn't. We'll talk about this when we talk about servicing. But you get that pan, the fluid out, replace that filter, put a new gasket on the pan, put it back on there, fill the transmission back up. This is the most common. There are some spin-on filters. I know Saturn had some spin-on transmission filters. It looked just like an engine oil filter. The Allison in the GM trucks have a spin-on filter. They also have a filter in the pan. The idea was the filter in the pan, the only time you did that when you were doing repairs. For some reason you had to have the pan off. And the spin-on one was the one that you did on regular services, was the one you replaced there. There are some transmissions, and more transmissions are like that, where there's not a replaceable filter. There's not a pan to move and replace the filter. If there's a filter element in there, it's the only way to replace it is actually to take the transmission apart. That is becoming more and more common. The idea is that they think that they're running cleaner and cleaner. The units are sealed up tighter, especially as we're seeing less and less dipstick tubes on transmissions. So we don't need a filter to change. Now that we're done talking about filters, we're moving to coolers. We need a way to keep our transmissions from overheating. They can overheat just like an engine. They don't produce as much heat as an engine does, but they can still get hot. And especially when we start talking about torque converters, we'll talk about how fluid can create friction and get hot. Kind of your ideal temperature of an automatic transmission is about 170, 180 degrees. That is where they want to kind of get that transmission temperature to. It's not too cold, not too hot. Excess heat destroys a transmission. This is probably the #1 killer of automatic transmissions, is excessive heat. Transmissions can operate up to 260 degrees. Ideally, we don't want them that hot, but if you're towing a bigger vehicle or you're towing a lot, you could see that transmission temperature get up there higher. Most average vehicles, once they get up to operating temperature, you're going to be at the 170, 180 degrees. Some common causes of high transmission temperatures: towing, stop and go driving, a lot of driving in hills and mountains can increase the temperature of a transmission. If you have a defective automatic transmission cooler, whether it's a restriction or air's not getting through that cooler, maybe the engine's overheating, engine's running a little hotter, which makes the transmission run hotter, and we'll talk about how that is here in a second. Or just transmission malfunctions. Maybe your torque converter's slipping more than it's supposed to be slipping, and that can create excessive heat within the transmission. Here's a chart to kind of show you that correlation. If your transmission operates at higher than an ideal temperature, you can expect to service that transmission more often. A lot of transmissions nowadays, they tell you at 100,000 miles. We'll get into servicing it. I usually try and do it before then, but the main point of this, you can see 175, that's right in your ideal range. They're saying you can get up over 100,000 miles where you got to change the transmission. But as that temperature increases, you can see where they start telling you you can have failure of your transmission fluid if you don't service it at a much lower mileage. That's why vehicles that tow a lot, you want to put them on a shorter maintenance interval for servicing their transmission. When we're talking about transmission coolers, the only way it cools is if we can get that transmission fluid from the transmission to a cooler. Transmission oil flows as soon as the pump starts to turn. So when you start that engine, pump in the transmission turns and it starts pumping fluid. The fluid exits the pump, it enters into the torque converter. And we'll talk more depth about torque converters, but we need that fluid in the torque converter for that torque converter to even work. That's one of our purposes and functions of transmission fluid. If we did not have fluid pressure in the torque converter, there'd be no coupling, fluid coupling in the torque converter, and we wouldn't get any power transfer from our engine into our transmission. After it enters the converter, it exits the converter, goes through some passages in the transmission case, and goes through a steel line to a cooler. This cooler most often is mounted in the outlet side of the radiator. That's the cooler side of the radiator. This is the most common way coolers are mounted, and we'll talk a little bit how coolers are mounted here in a minute. But that is the most common place where cooler is located, factory, is in the radiator. It goes into the cooler on one end, goes through a steel line into the cooler, then goes through the cooler back into another steel line where it goes back into the transmission. It is then routed through the transmission for lubrication. This is when all the parts of the transmission are lubricated. So you can see why it's important that this is not too hot. Fluid breaks down when it gets hot. Fluid viscosity breaks down. You don't get proper lubrication. You damage internal transmission components. Okay. From there, it gets returned back to the pan. If it doesn't have a pan, just in the sump of the transmission. Here's a diagram of that. As you can see, it leaves the transmission. It's already went from the pump into the converter. Out of the converter, it comes into the steel lines. You see the green lines are steel lines. Up into the cooler. Out of the cooler, back to the transmission. In most cases, when the transmission's all warmed up, this cools the transmission. In colder weather, they use this to actually get the transmission warmer. That's why it's in the radiator. Because remember, an engine is going to run about 195 degrees. That's about where most thermostats are. So that coolant in the radiator, when the engine's fully warmed up, is about 190, probably less than 195 degrees because it's in the radiator. But it's going to be about, you could see 180 degree water in that radiator. And that, when the transmission is cool, because it takes the transmission longer to heat up than the engine, that helps the transmission actually warm up faster. This is where, when at the very beginning of my objective to talk about heaters, some vehicles will have a valve, some will actually have a heater that actually helps heat the fluid in the line, but many of them will have a valve in there that is temperature controlled, that and it'll have an external or auxiliary cooler, so it doesn't run through the radiator, that will actually keep the fluid from going through the cooler till the engine gets up to operating temperatures. You see those with vehicles that have auxiliary coolers, and we're getting about ready to talk about those now. Again, we talked about most coolers are located in the outlet part of the radiator, the outlet tank of the radiator. Some vehicles have auxiliary coolers on them. They may be standalone to where that's all they have. They don't run it through the radiator. Those are ones that you see with the special valve on them that don't allow it to circulate through that cooler until that temperature of the transmission gets up to a certain amount. Once it gets up to a certain amount, that valve moves and then it'll circulate through the cooler. That's important when we start talking about flushing coolers after we've done a transmission replacement or overhaul. That's important when we're talking about doing a flush and fill of a transmission. If it has those valves in it, we need to know it, and we'll talk about that when we get into servicing transmission. Some vehicles will have it one in the radiator and an auxiliary cooler. Some of the ways they mount these is kind of two ways when they have both of those. They'll have it to where It goes through the radiator, then into the air cooler, then back to the transmission. Most of them will run it through the air cooler, then through the radiator, then back to the transmission. They do that especially for colder climates, because in colder climates, we want to get that transmission up to temperature. We don't want it to run at 50 degrees. We still want to get it up in temperature. So it'll cool it pretty good in the auxiliary coolers, because we don't have hot coolant running over these auxiliary coolers. We run it through the auxiliary coolers, through the radiator, it warms it up. But when everything's warmed up and hot, it helps keep that fluid cooler before it gets back to the tank. Auxiliary coolers are most of the time mounted in front of the condenser. What you have is you have your radiator, then in front of that, if you have air conditioning, you have a condenser in front of that. Then in front of that, if they have an auxiliary cooler for the transmission, they'll mount the auxiliary cooler in front of that. The idea is they want the air passing over that first, because that helps the, and we'll talk about construction of auxiliary coolers here in a minute. That air flows over those that cooler and removes the heat from the transmission fluid. These are what they call fluid to air coolers, just like our ones in our radiator are fluid to coolant coolers. They're trying to dissipate the heat from that fluid into that coolant. In auxiliary coolers, they're trying to dissipate the heat from that fluid into the air that's flowing over the cooler. When you take air conditioning class, you'll grasp the understanding of what heat exchange means. Heat, we do not cool things, we remove heat. That is how heat energy is dissipated, is we remove the heat from an object. We don't cool it. So when we're running transmission fluid through a cooler, we're removing that heat. Some common auxiliary cooler designs. Some of the most common is tube and fin and stack plate. And I have pictures of these. Let me go ahead and switch to those, and we'll talk about each cooler as we get to that picture. Here's a common tube and fin cooler. As you can see, you got tubes running back and forth in a crisscross pattern, almost like a snake, running through thin metal fins. The idea is this fluid runs through those tubes, air flows across those fins, the heat from that fluid is pulled into those fins, and then the air removes that heat from the fins. Okay? Your better tube coolers have what they call turbulators in there. Basically restrictions that causes that fluid to change direction and mix. Because if we didn't have those at all, you would just have fluid running through this big tube. The outer cooler fluid gets cool, but the inner never really gets that cool. These are not extremely efficient coolers. Okay? They're cheaper, but they're less efficient than our next kind. Our next ones are stacked plate. Again, we've got thin plates that the fluid goes through almost in a crisscross design, and being thin, more of the fluid, surface of the fluid is exposed to that air, so it can actually cool more of that fluid. Also, the design of these is they don't necessarily run in a tube back and forth. Say if our top row of our stack plate, that top tube gets plugged, it's capable of still flowing through the rest of it. Where in a tube and fin, where it'd be much harder to plug that, if it does become plugged, there's no fluid flowing through that tube and fin cooler. Matter of fact, when I recommend people, if they want to put transmission coolers on, I don't even recommend tube and fin coolers, because they're only really efficient on a moderate level, and for the most part, if you're not really doing any towing or hard driving, you don't need an external cooler. Your stack plate are much more efficient. They're more expensive, but they're much more efficient. In many cases, if you live in a moderate climate, like here in the Kansas, you can do away with your cooler and your radiator and just use an auxiliary cooler. The other thing about auxiliary coolers is they're rated for a certain size, for certain BTUs. You need to understand, figure out how much BTUs of heat exchange you need, and that'll determine how big a cooler you want on your vehicle. If I was doing some heavy towing, I would use an auxiliary cooler only. That would really save the life of the transmission. Now, if I was in an extremely cold climate, I wouldn't do that. But say here in Kansas or southern states, if I was doing any heavy towing, I would use an auxiliary cooler only. That'll really extend the life of your transmission. Again, heat is the death of many transmissions. Now that we've kind of talked about fluid, we've talked about coolers and filters, you see the importance of keeping the right fluid in your vehicle, making sure we keep that fluid cool. We want to make sure we keep good fluid in it. In other words, and we'll talk about when we get into servicing them, how to diagnose, my fluid's starting to look kind of old, I want to change my fluid. But maintenance on automatic transmissions are important, and we'll talk about that when we get into servicing them. Our next little bit in this lesson is towing an automatic transmission. If the wheels are turning on that vehicle, if the drive wheels are turning on that vehicle, components in that transmission are turning. But if the engine is not running, the transmission pump is not pumping fluid through that transmission, means you're not getting any lubrication. If we are towing a vehicle with an automatic transmission, if it's in a short range, a few miles, and as long as you don't go too fast, definitely not over 25 or 30, you'll probably be perfectly fine towing the vehicle. If your drive wheels are turning, you probably won't do much damage. If you want to tow it faster or have to tow it faster or over a longer distance, we need to take other precautions. If it's a rear-wheel drive transmission where you can remove that rear drive shaft, do it. Because if the drive wheels are disconnected from the transmission, even though the drive wheels are turning and the transmission's not, it doesn't need to be lubricated. Some four-wheel drives, if you can put them in the transfer case in neutral, depending on the construction of the transfer case, many of those you can put the transfer case in neutral, then go ahead and tow it. All-wheel drive vehicles, you're going to want to get it on a flatbed truck and tow that. Okay? Take precautions, because if you tow it over a long enough distance or fast enough speed with no lubrication, you're going to ruin components. You're going to ruin a transmission. Okay? Your best bet, if you have to tow that any distance and you cannot remove the drive shafts, get a tow truck. Get that towed properly. Because even if you have to pay 100 or 200 bucks for a tow truck, that's a lot cheaper than 1,000 or more on a transmission. Okay. Here's just a diagram. The one up there is one on top is supposed to be all-wheel drive. They're putting on a flatbed. The one on the bottom is rear-wheel drive, so they're I guess both of all-wheel drive, and they're putting dolly wheels on the front. If it was rear-wheel drive, maybe you'd lift up the back end, pull it from the front. A lot of your tow trucks, especially on bigger trucks, will go ahead and remove the drive shaft. Front-wheel drive vehicles, all they need to do is lift up the front of the vehicle. But you kind of get the understanding of, we want to make sure if those drive wheels are turning and it's still connected to the transmission, we want to make sure that we don't tow that very far or we can damage the transmission. All right, that'll be the end of this lesson. At this point, I'm going to encourage you guys to make sure you're reading in your book. There's not a lot of chapters in your book, but that'll come in very handy to help you on your tests. Almost all your test questions, at least a lot of them, are pulled from that book. There are some that aren't in there, but many of them are. So make sure you're reading that book. Our next lessons, we're going to get into torque converters and the actual hydraulic system of our automatic transmissions.